we are recording.
Where do you think we will land?
And we're going to try a live lecture.
So many words.
And basically, anybody can ask questions at any time. You can ask in the chat, or you can ask using your microphone. You can interrupt at any time. It's absolutely fine. I will be switching back and forth between the PowerPoint slides and the Teams chat every so often to see if anybody has any questions. Yeah, and we'll see how that goes. If I try to have Teams and my slides open at the same time, I think that the slide font gets too small and that people have trouble seeing the slides. So I'll be switching back and forth, and we'll see how that goes. If I lose my sound or anything, people will have to inform me that the sound is gone. Okay, so today we're going to talk about documentation and version control. Hopefully some of you, or maybe, well, most of you have either heard of these concepts or at least had some experience with them already. But in case not, this lecture doesn't require any previous experience in any of these topics. So we're going to start off by talking about Javadoc. So I think that everybody knows by now that commenting your code is important if you want it to be understandable by other people and understandable by yourself. You might actually write code and then put it away for a long time and then come back to it and find that you can no longer read it anymore. If that happens to you, it means that you're doing some things wrong, but one of those things is not including comments. And there are different tools that can help us comment our code. So there are some so-called semi-automatic documentation tools. Right? One is called Javadoc, another one is called Doxygen. There are multiple versions of different kinds of tools, and they provide a standard. They provide essentially a code comment standard. So a standard way to structure your comments, standard information to include in your comments, and a standard output. The output also is standardized. The two most popular documentation tools for source code are Doxygen and Javadoc. Javadoc is specifically for Java, surprise, surprise. Doxygen is more generalized and applies to other languages like C+ and C#. And in reality, in practice, Doxygen is actually a little bit better than Javadoc because Doxygen produces graphs, collaboration graphs, inheritance graphs, and those kinds of graphical representations of the code. However, we're teaching Java. We're going to stick with Java in this semester. But when you go out into the real world and you get your first software engineering job, I encourage you to actually use Doxygen. And I actually introduced Doxygen to the last company that I worked at. And then they adopted it for their actual commercial software. A lot of these documentation tools are built into your integrated development environments, which is no big surprise, right? And they're essential for creating maintainable code, especially when the code and the programs and the applications are getting bigger and bigger and bigger. The bigger they are, the older the software is, the more important these kinds of documents and these documentations are important, right? They're not so critical if you're writing a hello world program, but if you're writing an actual commercial application or something big or something that's designed to last a long time, then the comments, these tools are absolutely essential. Right, so Javadoc is what we're going to use in this module. Does anybody remember if Max talked about Javadoc in last semester's software engineering? Anybody remember? No response. So I guess that means nobody remembers.
I think there's a delay in the chat.
Oh, okay, okay.
Yeah.
Yeah, there might be, that's a good observation. There might be so many people that Teams is having trouble keeping up and there might be a delay. Yes, that is certainly possible. So Javadoc uses special syntax for your comments. Right, one of the syntaxes is this /, 2 asterisks, and then there's a comment, and the comment end is indicated by an asterisk and another /. Right, this / asterisk comments and so on is a C style comment. And then there are lots of tags. Those tags are very similar to XML, right, or HTML, right? So some of the useful tags, or the most common so-called tags, are this param tag. So that is how you describe a method parameter, right? All methods have parameters, or most methods have parameters. So to describe what that parameter is, you'd use this parameter tag. To describe what a method returns, there's a return tag. And then there are these other tags for exception handling, right? If you write a method that throws an exception, you can document what kind of exception it throws and how it's handled. There's a deprecated tag that lets you know when methods are on their way out or getting old or being replaced by newer versions. This one's also very helpful when you actually want to put, when you want to preserve the syntax of what you write and the spacing, you can use this code tag. Obviously, there are lots of these tags. These are just some of the more common ones. I'm going to attempt to show an example. Let's see if my, oh, it does work. Okay, I wasn't sure how slow or fast it would come up. This is an example of a very short program with some Javadoc syntax at the top. So the name of the file, the author of the file, the date that the file was created and when it was updated. I also have used this C tag, which means you can actually open a book called Diddle and Diddle, Java programming for Java for programmers, and look at page 383 to see this example of where I got it from. I have this brief tag, and that is a brief description of the class and what it does. And then I have a comment, and here's the end of my comments, right? The comment is, this version of the program has some serious flaws, can you see them? Anyway, that's not the point of today's lecture, but that's just an example of what the Javadoc documentation looks like. And this is what you use to document your code. Does anybody know what a good example of Javadoc output looks like? Can anybody think of some a good example of Javadoc output? Anybody feeling courageous? No, nobody's feeling courageous. If you want to see a good example of Javadoc output, let's see if this works. You can go to the Java API. So this is what the actual Javadoc output looks like. Right, and there are all the classes. These are packages, these are classes. That brief tag that I mentioned appears here in the brief description. Before it's a short description that appears in a list as opposed to the detailed description. And these are all the Java classes. That's some serious that's a serious library right there. That's a lot of classes. But anyways, all of these classes have been documented with Javadoc, and this is what the Javadoc output looks like if you want to see a very good example of that. Any questions about Javadoc? Javadoc is very easy. It's very simple, it's very easy, it just takes a little bit of practice, so we're not going to spend very much time on it. Any questions about Javadoc? If you do have questions, just let me know. You can use your microphone if you want to. You can type in the chat, but I'm not actually hearing any typing. Okay, Javadoc is a tool. It's an application that you can use to document your code. It's not really used, as far as I know, it's not used as a library per se. It's not used as like an API. You don't generally program Javadoc or extend its functionality. You just use it as an off-the-shelf tool. Okay, so, I didn't see that comment. Okay, I have to get some practice at this. So Max did not mention Javadoc. Okay, then that's good. That's good. I need to practice switching back and forth between the slides and the chat. Okay, let's look at version control. This is also extremely important. This is something that Max actually mentioned. I have been looking at his slides. I don't have them all memorized, but I have been glancing through them. But we're going to go into version control in a little bit more depth. And this week's lab is all about version control and setting up version control here at the Computer Science Department at University of Nottingham, making sure you have version control working for your coursework and the rest of your life. So why would you want to use version control? This is to track the evolution of source code. So basically you work, if you're a software developer or a computer science student, you're working on software on a daily basis, you're writing code on a daily basis, and you want something that facilitates the tracking of changes. It's very easy for anybody with a little bit of experience, it's very easy to work on a piece of software and break it. And sometimes you might have broken it so badly that you can't figure out what you did wrong. And you might just be thinking, okay, I want to just undo the things that I broke and start over again. So using version control will help you with that. You can recover older versions of source code that are working properly, and it tracks the entire history of all the source code. It's also very important for working in teams, right? Real software, big software, maintainable software is developed in teams. It's very rarely, if ever, developed as a single individual. So if you want to see my source code and check out my source code, you need to use a version control system. And that's what we're talking about today. These version control systems work locally, right, on your local PC or laptop, and they also work across networks for collaboration. And they track every change made to your software, and they manage concurrency. So that's when multiple people are using developing the source simultaneously in a team. We're going to use some terminology, maybe some terminology that you haven't heard yet. There's a term called the repository. So the repository is the folder where all of your source code and its derivatives and its history are stored, right? They're stored in a repository. And here is an image of a repository. It can also be called a file system tree. And we have local repositories. Those are the repositories that sit on your computer, on your, we call the client. And then there's also the main or the server repository. And that's the storage space where the entire team archives their source code. And you can see these different operations, right? You can write to the repository. Writing means saving your changes, modifying some source code, saving the changes to the repository. Read means checking out source code, either your own that you've written previously or somebody else's that they've written previously. And version control handles this concurrency management. Right, what is, just in case you forgot, concurrency means simultaneous occurrence or coincidence. In this case, concurrency means developing in software in parallel with a team, with other developers. Right, if you're all developing software and you're all trying to contribute to the same application, you need a tool that manages this process, this parallel development process. And that's what we're talking about in the next few slides. And there are different ways to deal with concurrency or working in teams. We have to figure out how to share files, for example, and we have to figure out how to merge files so that they don't conflict with one another. Right? And that's what we're going to talk about in the next few slides. Right, so what am I talking about? Imagine this scenario. This is a diagram that shows a case scenario, right? We have a repository and two users want to read the same file. Now, in this case, every file is a source code file, like hello world.java, for example, right? There's a team all working on the same software project, and two users, Harry and Sally, want to read the same file. Now, what happens then if they both start to edit the file, right? Harry starts to edit the file, and Sally starts to edit the file. Harry's edited copy is notated with this letter A and then an apostrophe. We call that A prime. Sally's copy is annotated with this A double prime, this A parentheses, two parentheses, apostrophes. Now, what would happen if Harry decided to save his changes into the repository? You can see that in the lower left. So Harry decides to edit the file and then save his changes in the repository. You can see the file A prime has now been saved as the file A prime in the repository. And then what would happen if Sally decided to save her version in the repository, right? A double prime. If there was no version control, Sally's version, A double prime, would just overwrite Harry's A prime version, and then Harry would get very angry. So we want to avoid those kinds of conflicts. So that's what version control facilitates, these kinds of these kinds of concurrency management problems. So one is the lock, modify, unlock solution. Has anybody here heard of, taken any database classes? I will stop and check for answers in the chat. Anybody taken a database class before? So some of the terminology we're going to use with this locking and unlocking is very analogous to database terminology. So if you're thinking about databases in this context, then you're on the right track, because this is very similar or very analogous to making a database query, right? A database query is an atomic operation, and so this is trying to autonomize the concurrency. So here's a solution to the problem. Harry locks a file A and then copies it for editing, right? So Harry, there's a lock symbol on this file called A. Harry locks it, and then he downloads a copy of it, or he reads a copy of it. And then he starts to modify the file. So you can see that by this A prime symbol. Right, he's modified the file, and guess what? Sally tries to read A. Now, Sally can read A, and that's fine. She can download a copy of A, read it, but she will encounter a problem when she tries to start editing the file. In order to edit the file, she would need to unlock it and then make the changes. But because Harry has already locked, the file is locked and he has a copy of it, Sally can no longer unlock the file and start editing. Harry can do his editing, and then when he writes its file or saves his changes back into the repository, he unlocks the file. Right? So there's a write, and then there's an unlock operation, and you can see A prime, there's a copy of A prime, which is the updated version of file A in the repository. Now Sally, if she wants to, can unlock the file and read it and make some edits, right? Can anybody see any limitations with that approach? There are limitations with that approach. I hope everybody can see my slides, by the way. Can everybody see my slides? Okay, yes, only one person at a time, that's right. That's one of the limitations. Here are some more limitations. Harry can lock a file from the repository and then forget about it by accident. He could go on vacation, right? Here you would call it annual leave. That's a problem. It sounds silly, and it is silly, but it happens. This definitely happens in reality. There's no question. This happened pretty regularly at my last job, at one of my previous jobs. Serialization means, yes, that only one person can work on the file at the same time. And somebody can still break files. It is still possible to break a project. There's no protecting the dependency between files, so it can provide a false sense of security. Here's another solution. It's called the copy, modify, merge solution. So Harry compares his own version to the one in the repository, right? So he sees there's a double prime in the repository. He reads A prime, his own version, and the double prime version. And then he tries to merge the two files, right? And after he's working on his merged version, he checks the new merged version back into the repository. That merged version has this A+ symbol there. And then when Sally downloads the new version, which has this A*, is denoted with this A* or A* symbol, she gets the merged version. So this can work. It's possible to get this to work, the copy, modify, merge model for text files, right? Users can work in parallel. Sometimes the version control can automatically merge the changes and resolve conflicts. This is not going to work for binary files. Another disadvantage, though, is that these merges are not always predictable. So in practice, the copy, modify, merge solution is not, I wouldn't recommend that either in practice. In practice, the best way to handle this is only one person works on a class, generally. So each class is assigned to a person, and only one person works on that class. And that's how the software is divided up. That's the best way to handle this kind of concurrency in practice, actually. You don't want a situation where a whole team of people are trying to modify the source code of a single file. There's going to be lots of problems in this case. You want to divide up the project so that each class is modified by one person in general. Of course, there are exceptions, but as a general rule, that's a good process. If you have a whole team, 2 or more people trying to compete for the same source code file, there are going to be problems. There are always going to be different kinds of problems. Okay, some more terminology. Working copy. This is actually kind of configuration management or administration more than software development, but for better or for worse, software administration is part of the software development job. So another term that's used frequently is a so-called working copy. Right, and in the repository you have the entire project with its entire version history stored in a directory tree. It doesn't automatically, your working copy does not automatically synchronize with the repository, right? So the working copy is a copy of the repository on your local computer, right? The repository is typically sitting on a server computer, and then in order for you to develop it further, you need to download a so-called working copy, which is the latest version of the software, so that you can make changes, right? That's what we mean by working copy. And a typical repository, by the way, is several projects in parallel. Usually, if you're working at a company, they're working on multiple products. So a repository has multiple products, and then each project gets its own subdirectory. And a working copy is one of those subdirectories. Typically, you're not working on more than one product if you're a software developer in a company. Typically, you are assigned to one product or one subdirectory of in a typical repository. Any questions so far? I will check the chat just to make sure. Let's see if I can see that question. What's a binary file? So a binary file is a file that you generally cannot edit with a text editor, right? So you can tell if a file is binary by looking at its file extension, for example. If it has the extension .txt, it's a text file, and you can edit it. If it's got the extension .java, it's a source code file. A source code file is a type of text file, and it's editable. But a binary file does not store text data, generally speaking. A good example of a binary file is an image. So a PNG image file, or a JPEG image file, or a video file like a .mov, QuickTime movie file. Those are all examples of binary files. So they store binary data as opposed to ASCII data, for example. That's a binary file. Okay. Here's just a little kind of toy example illustration. Here's a repository file system. Here's the root of the repository. It has two sub-projects. One's called Calc, another one's called Paint, right? A calculator and a paint program. They have make files. Make files are those files that they're a set of commands that compile all the files. So they're just a set of commands. Right? A common action in version control is to check out a file. So that's that process of locking a file and then downloading a copy of it so you can edit it. So here's a typical command that downloads a copy of a project. So you have your local working copy. And then you have these three files, right? These three files over here depicted in a diagram. And then, of course, every time you check out some source code, it has some version, right? A version number. So, and then we can modify, for example, button.c. And after we've made our modifications, we can check that code back into the repository. And that's done with a command that looks like this. So the version control program we're going to be looking at is called Git. And it's a command line tool. However, in the lab, we're going to be looking at both sort of GUI options for version control and command line options. So Git by its nature is, or version 1.0, let's say, is command line, but you don't have to memorize all the commands. And we'll go over that in the lab, actually. So this is a typical command on how, after you've edited your source file, to check it back into the repository and unlock it so that everybody else can see the changes you made. So a commit publishes your changes to any of the files that you submit, right? It's a so-called atomic operation that's from databases again. It either fails or succeeds. There's no halfway. If it fails, you have to start the process over again. That's very rare, by the way. I don't remember that ever happening to me. And a commit means a new state, the repository state has changed, and therefore the tree has been edited and revised. And all of those commit operations will result in a new version number. So every file, every source file will have a version number. And you can see the entire history of how many times a file has been checked in and how many times it's been checked out, who checked it in, when they checked it in, or who checked it out and when they checked it out. So if somebody does check out a file, start editing it, and then they go on vacation, you can still download a copy, read it, and find out, oh my gosh, it was Joe. Joe has checked out this file, and now he's on vacation. And then everybody starts screaming and panicking. Anybody know how that problem is solved in reality? You'd have to have worked at a company to actually know the answer to that question. Yes, that's one that there's always an administrator. So there's always a so-called configuration manager that oversees the repository and the checking in and checking out. So the administrator, if he wants to, can break the lock of any user. And then the guy that went on vacation essentially is, his changes essentially get lost. So whatever changes he made, they get lost. But that's not such a big deal because he broke the rules by checking out a file and then going on vacation. Okay, update is another common operation. So imagine you're a software developer working in a team. This is a very typical operation that you do first thing in the morning when you want to get the latest version of the software onto your local machine. Right? So you might perform an update that says, please show me everything that's new and has changed since yesterday, so I have the latest version on my machine. While I'm at it, one comment I should mention is a good time to check in code is, there are two good times to check in code. One is after you've tested it and you're sure it's working. So imagine you're trying to add a feature. You add a feature, you've tested it to a degree where you think it's actually working. That's a good time to check in a version of your source, is after you get it working, so with some new functionality. Another good time to check in your source code is at the end of the day. So typically it's like you download the latest copy, you make some modifications, and you've added some new functionality, and now it's the end of the day, so you've put in something like, 8 hours of work. That's a good time to check in the file again, assuming that it's working. You never want to check in a file that's broken, that breaks the whole application. But the two occasions are after you've got a new function working properly and you've tested it, and at the end of a working day. And if you do that, those are good times to check in source code. So in this module, we're going to be using a program called Git, which is a very, probably the most common version control piece of software in the world. I'm guessing in the world. It's free and it's open source. And its origins stem from Linux, the Linux operating system, and it was a version control system specifically for Linux. It was originally designed for command line use, and we're going to see the different commands in the lab. But you can use a GUI. You usually, in practice, you're usually checking in and out files through your IDE. Right, and then there's a server that hosts all the source code, and in our module, it's the server is called Git Lab, and the URL for that server is here. Git is very old. Well, it's old. I don't know exactly how old, but it's old. So it's very mature. It's very well documented. It's very commonly used. And here are some resources. I actually made a step-by-step video demonstration of setting up Git in Git Lab. and I'm actually going to be walking through that during the lab. It has no sound, and so on this week's lab, I'm actually going to add sound, my voice, to that tutorial. And then there are other resources. There are lots of Git resources because it's a very mature and well-documented tool. So in Git, we start off by specifying a project folder like Bob's Amazing Project, and then Git will track the history of all the changes that you make to that project. Every time you check in a file, every time you check out a file, every time you make changes, what those changes are, and basically the entire history of a piece of source code or a project or multiple projects, right? So Git reports creating the repository, committing code, file transfers back and forth, and then rolling back in case there's a problem. So that's called a reversion, reverting back in case something breaks, and managing history. By the way, another great reason, which I forgot to mention, to use version control is to keep a backup copy of all your work. The importance of this cannot be underestimated, right? You could be working on a software project and your hard drive crashes and you can't get anything off of your laptop or your computer anymore. If you're using version control, like we want you to in this module, then you will have a backup copy of all your work on the Git Lab server, which we're going to talk about more in the lab. Right, so these are just some of the things. So Git handles all the concurrency that we talked about, right? This merging and these coordinating between team members. And so Git will handle this. It handles forking and branches, so creating different versions of a piece of software. Maybe you have an application that you want to run as a mobile phone app, a desktop app, and a tablet app. So you would create different branches. You would fork the master branch into different platforms so you can make the modifications required for the different pieces of hardware to run your software on different pieces of hardware. And that's what branching is all about. Right, so it will keep the branching are all those subdirectories from the master copy. So the tools for using Git, there are command line tools that we can download. They're open source, they're free. That's what that video demo that I mentioned in the last a few slides ago talks about. You could use Git as part of an IDE, so as part of Eclipse or IntelliJ or NetBeans. I'm actually going to use NetBeans, which you probably maybe never saw before. You can use web browsers, actually, so that's a very nice feature. And then you have a client application, so to speak, and then there's a server side to the Git, which is the Git server. And that's where the repository is held, right? The main repository. Here's a tool that provides an interface for Git. In the lab, I'm going to demonstrate how to use Git in Git Lab in combination with NetBeans, which is another IDE. So far you've used Eclipse and an IntelliJ. I happen to like another IDE called NetBeans. And I'm going to demonstrate how to set up NetBeans on your local computer and how to get Git and Git Lab working with NetBeans. Okay. That's it for today. Any questions? Any questions about Javadoc or whatever else I talked about, version control? While we're here, I did put in this one note, freetechbooks.com. I hope that everybody knows about freetechbooks.com. Freetechbooks.com is a huge resource when it comes to software engineering. Here it is, Free Tech Books. So if you want any books on any software engineering topic or any programming topic, you can get it from this website. There are hundreds of books about Java development. There are hundreds of books about everything, version control, whatever you want, right? Look, book categories include computer science, mathematics, related fields, operating systems, programming, and so on. There are thousands and thousands of books. Python books. Okay, here's a new one, free and open machine learning, and so on. I just hope that everybody knows about this webpage. So you have like essentially an infinite list of different books that you can have for free at your fingertips. And it's legal. Yeah, probably you're all using the illegal stuff. So the next lab is getting Git and Git Lab working. So you need to use version control as part of your coursework. And the version control system we're going to be using is Git. Git is the name of the client software, and Git Lab is the name of the server software. The server is already set up at the URL that I mentioned. I think it's projects.cs.nottingham.ac.uk. But we're going to show how to install the Git client on your computer. You don't have to do that, but I think it's a good idea, and I'm going to demonstrate how to do that. But the lab is all about setting up version control and getting it working. You know, that's what the lab is. The coursework. So the coursework essentially is you're given an application. I'm trying to remember what the application is. It's a game. You're given an application. It's a game, and you have to do a few things. You have to fix problems with the game, and then you have to add new features. That's the essence. I'm simplifying it in a big way. But that's the essence. It's like, here's a piece of software, it's a game, it has problems, right? It has problems with the source code, it has problems with the design. See if you can fix some of those problems, and see if you can add these new features. And while you're doing that, you want to be managing your source code with version control, right? Version control is going to be one of the tools that you use to manage your coursework. Any other questions? When will the coursework be released? I don't know, actually. It will be released the day before it's due. I don't actually know, but I think it's going to be very soon. I think it's going to be within the next 2 weeks. Peer is kind of spearheading the coursework aspect, and so we need to check with Peer on the exact date. This coursework is an individual project, so you're all doing it individually, and there's a reason for that. The reason is because you're already working on a different project that is a group project. So the logic was, there's a group project module already, so this one will be individual. Maybe having 2 group projects would be a little bit too much. Yeah, so this one's individual. I'm glad everybody's bringing their questions. Any other questions before we wrap up? I will do my best to upload the recording of this lecture as soon as possible. I'm in this kind of I don't know what you call it, a predicament maybe, but I'm trying to prepare lectures. So that's the work that's required to deliver them before they happen, and now there's this post-processing work. So right now I'm trying to prepare lectures and I'm trying to process them for archiving. So there's kind of 2 competing processes going on at the same time. But anyways, I will post-process these lectures, the lecture recordings, as quickly as I can and upload them for viewing as quickly as I can. Any other questions? Okay, I will see everybody at the lab. By the way, the lab is going to be a little bit different. It is going to be live, but I'm going to give a presentation, like a demo presentation to start the lab off. So the first part of the lab is going to be me giving a kind of demonstration. It's going to be a demonstration of NetBeans, which is the IDE that I like to use, and Git. It's going to be NetBeans, Git, and Git Lab, all 3 of those things. And that's all about getting your version control set up and working, essentially, for your coursework and for your life. Because once you start using version control, you want to use it for the rest of your life. Otherwise, you will have occasions where you regret. Where can you use? So on this week's lab, I'm going to demonstrate how to use the IDEs on your local computer. Assuming you have your own laptop or your own desktop machine. You can use these IDEs in the lab if you want. There are ways to connect to the lab machines. I prefer to work on my own machine, so I'm going to show you how to download and install an IDE on your own machine. I would encourage everybody to experiment with using the IDEs and the version control on your own machines. There's no reason not to unless you don't have a machine. But if you're a computer science student, you want to try to get your own machine somehow. So in this week's lab, I'm going to demonstrate how to use your own machine to install your own IDE on your own machine and get Git and Git Lab working on your own machine. My machine, by the way, happens to be a Mac. Hopefully there are some other, but this download and installation process is not going to be dramatically different for the different platforms, I think. Okay, I think we can wrap it up for today. Are there any pressing questions? I would suggest that we wrap it up for today. If you do have pressing questions, you can bring them to the lab, and you can bring them to the next lectures. You can also ask me, offline as well. But it's more interesting. It makes the lectures more interesting, I think, if people ask questions, as if we were in an actual lecture. Yeah.
Do you know where you've been?
Okay, thank you all very much, and I will do my best to get the rest of the lectures prepared in the recordings. Thanks, everyone.